Those who are present in the online or Zoom meeting, can anyone confirm, please? Am I audible or not?
Yes, you are very much audible.
Thank you, sir. Just wait for 2 to 3 minutes. We are starting in a while. Okay. So it's my request. Just wait for 2 to 3 minutes. We are starting in a while.
Very good morning, everyone. We are just waiting for the Vice Chancellor, sir. He will be there within 2 or 3 minutes. So we will be start at 9:40. Till then, I will ask you to wait here. Thank you. Very good morning, ladies and gentlemen present here. I extended a warm welcome to all of you on the second day of second international conference on human-centric smart computing 2023. My name is Jyoti Khandelwal and I am delighted to be your host for today's proceeding. Before we proceed further, I would like to take a moment to introduce our distinguished guest for today. We have with us Professor Dr. Vijay Chatterjee, Chancellor, University of Engineering Management, Jaipur. Professor Dr. Anirudh Mukherjee, Dean, University of Engineering Management, Jaipur. And our estimated keynote speakers, Professor Dr. Tapas Sai, Associate Professor, University of Engineering Management, Jaipur. Professor Dr. Vijay Ketan Panigrahi from IIT, New Delhi. So I welcome you all in this session. Before we proceed further, I'd like to introduce our next speaker, Professor Dr. Anirudh Mukherjee, Dean, University of Engineering Management, Jaipur, for the welcome address. Sir, Dr. Mukherjee has always been a keen in fuzzy industry requirement in academics. During his early 8 years in engineering, industry soon after his graduation from NIT Silchar, he has been associated with erection and commissioning of some of the prestigious power plant projects of the country. He did his postgraduate from Jadavpur University and his research involved evolutions of parameters involving life estimation of light sources. He has over 18 years of academic experience. His field of interest is being power quality, lighting design and engineering and electrical vehicles. Now I will request Dean sir to kindly proceed and deliver his address.
Am I audible?
Yes, sir, you're audible.
Thank you. Thank you, Professor Jyoti Khandelwal, for this introduction. Well, this is a great moment for me. I'm really honored to be a part of this conference, ICH CSC 2023. I really thank from the bottom of my heart and welcome all the distinguished guests, Honorable Vice Chancellor Sir, and I really thank from the core of my heart the Director of Institute of Engineering and Management, Professor Dr. Satyajit Chakravarti. I have been listening to the speakers yesterday by the distinguished speakers who were there in the conference, Professor Dr. Siddharth Bhattacharya, Professor Dr. Jyoti Shekhar Banerjee, and many more. I'm sorry if I have missed some of the names. So it's really a great pleasure to welcome you all on the second day of the second international conference on human-centric smart computing. Today we gather here to explore the transformative power of technology and its potential to enhance human lives, to foster sustainable development, and as I believe, to shape a brighter future for all of us. In this era of rapid technological advancements, smart computing has obviously emerged as a key driver of innovation, revolutionizing the way we live, we work, and the way we interact with the world, from the IoT Internet of Things to artificial intelligence, from big data analytics to blockchain technology. The possibilities seem boundless. However, amidst this wave of progress, it is imperative that we keep our focus on the human aspect, which I believe is a very important part, the individuals who stand to benefit from these innovations. So what I believe the human-centric smart computing is not just about creating intelligent systems, it is about designing technology that serves humanity. It is about putting people at the center of our endeavors and ensuring that the benefits of smart computing are accessible, inclusive, and sustainable. Technology should empower individuals and should bridge gaps and address societal challenges rather than uh, I mean, rather than, exacerbate inequalities or marginalize certain communities. Today, we have the opportunity to engage in fruitful discussions, explore cutting edge research, and learn from the experience of experts in various fields. Today, together we can delve into topics such as human computer interactions, because it's very important for us to understand the interaction, human computer interactions, the user experience, design, the ethical considerations in smart computing, privacy and security, which are also very, burning topics nowadays, and the impact of smart computing on education, healthcare, and social well-being. Moreover, as we explore the future of smart computing, we must also be cognizant of the environmental impact of our endeavors. Sustainable development must be at the core of our technological advancements. Yesterday, I was listening to our Register Sir's speech. He mentioned in in a segment that the impact of the environmental impact on this artificial intelligence. You can understand the supercomputers, that the computers that need to run, the huge amount of energy has to be provided to that, and that drains out a lot of water from the system in order to keep it cool. So we want to maintain the temperature. So there are also aspects of environmental impact. So that has to be looked into, and sustainable development must be at the core of our technological advancements. We must focus on that. We must strive to minimize resource consumption, reduce electronic waste, and harness renewable energy sources. By adopting a human-centric and environmentally conscious approach, we can build a smarter, greener, and more equitable world. I encourage each and every one of you to actively participate in the conference, to engage in thoughtful conversations, and to foster collaborations that will benefit our university by and large, that transcend borders and disciplines. So let us embrace diversity, innovation, and the power of collective intelligence. So together we can shape a future where smart computing truly enhances human lives, promotes well-being, and paves the way for a more sustainable and inclusive world. On behalf of the organizing committee, I extend my heartfelt gratitude to our sponsors, keynote speakers, to all of them. If I have missed out, I am deeply sorry for that, and all the participants for their contributions and support. May this conference serve as a stepping stone towards human-centric, technology-driven society that benefits all of humanity. Thank you, and I wish you all a fruitful and inspiring conference. Thank you.
Thank you, sir, for your unending support. We are honored to have you in this address. Thank you, sir. Now, without further ado, it is my pleasure to introduce our keynote speaker for today, Dr. Tapas Sai. Dr. Tapas Sai holds BTech in Computer Science and Engineering from Maulana Abdul Kalam Azad University, AmTech in Information Technology from International Institute of Technology, Durgapura, West Bengal, India, and PhD in Engineering from the same university. He is currently an associate professor in the Department of Computer Science and Engineering at the University of Engineering and Management, Jaipur. He has published 73 papers in reputed international journals and conferences. He served as a reviewer for Journals of Springer, Elsevier, IEEE, and the others. His research interests including machine learning, swarm intelligence, medical image processing, and medical data mining. He is listed in Who's Who in the World in year of 2016 and Marque's Who's Who in USA. He is a member of IEEE, Institute of Engineering, Soft Computing Research Society, and Machine Intelligence Research Lab. I'd like to call sir for his keynote speech. Please, sir.
Good morning.
Screen is not shared.
So it is shared, but online my face is visible. Online is it visible?
And screen is also online visible.
Yes.
Confirm for it.
Hello, is my screen is visible? Hello.
Sir, you need to share your screen.
Oh, okay.
Just kindly go over there.
Have to share the screen.
Oh, last one, last one.
Last one. Okay. Share. Now is it visible to everyone?
Yes, ma'am.
All good, ma'am.
Okay, thank you.
Good morning to all. My topic is meta-heuristic with opposition-based learning. And opposition means generally we take it in negative way, but there is huge scope of learning from the opposition. So by using this philosophy, opposition-based learning is designed by TUs. So this is the content of the presentation. Numerous types of opposition currently exist practically everywhere around us, but only in some circumstances within the discipline of philosophy, linguistics, psychology, logic, and physics are the nature and meaning of oppositeness thoroughly known. Using this philosophy, opposition-based computing in machine intelligence was introduced by H.R. Tijus in 2005. So heuristic is a part of an optimization algorithm that uses the information currently gathered by the algorithm to help to decide which solution candidates should be tested next or how the next individual can be produced. Generally, heuristics are problem class dependent, whereas meta-heuristic similarly use the same philosophy, but in an efficient way. Usually, it without using deeper insight into their structure, whereas heuristic use the information from the problem. Okay, so we should have knowledge of the problem we want to solve. But in case of meta-heuristic, we do not need to know a deeper insight of the problem we want to solve. So this is this is that we're treating them as black box procedure. So some example of meta-heuristics algorithm: genetic algorithm, biogeography based optimization algorithm, differential evolution, particle sum optimizer. So this is very well known and very reported optimization algorithm. Artificial bee colony, ant colony optimization, glow worm swarm optimization, firefly optimization algorithm, bat algorithm, cuckoo search, harmony search, gravitation search algorithm, teaching learning based optimization, sine cosine algorithm, so multiverse optimizer, whale optimization algorithm, moth flame optimization algorithm, gray wolf optimization algorithm. So I am give the names of few, but there are 500, more than 500 nature based algorithm that is mimicking the species in the nature. So Pyrox algorithm mimicking the explosion of fire in the sky at night. Dragonfly algorithm, ant line optimizer, spotted hind optimizer, slime mold algorithm, student psychology based optimization. Using the behavior of students and their psychology, student psychology based optimization algorithm is developed. Tunicate swarm algorithm, Siegel optimization algorithm, Salve swarm, arithmetic optimization algorithm. So this algorithm use simple multiplication, addition, subtraction, division operator. Artificial gorilla troop optimizer, equilibrium optimizer, and recently come that is fusion fission optimization algorithm from physics. So these are very few algorithms, but there are a list of more than 500 algorithms that mimics the nature, follow the nature. Now, opposition-based learning, basic concept in one symbol. So this is the symbol, and in represent the receptive, feminine, dark, passive force, and yang represent the creative, masculine, bright, active force. Next, Greek classical elements of nature patterns. So in this diagram, we can see that fire opposite is water, air opposite earth. So earth is cold, dry, air hot and wet, whereas fire hot and dry versus water cold and wet. So we need the opposite elements to make the balance in the universe. So using that philosophy of opposition, that opposition-based learning is developed. The basic definition is that if suppose let x be a real number having ascertained in the interval AP, so A is the lower bound here, B is the upper bound. The opposite number x check is defined as x check equal to A plus B minus x. This is the simple formula. For instance, if x equal to 2 is a point in the interval minus 5 plus 5, then the opposite of x is minus 2. So simply minus 5 plus 5, 0, minus 2, that is minus 2. Now, if the problem is multidimensional, that means if it is d-dimensional problem, that means we have d number of parameters. In that case, it is represented as x cap I equal to ai plus bi minus xi. Simple example, if x equal to 2, 1, it is a 2D point in the interval minus 5 plus 5. So the opposite point of x is x check equal to minus 2, minus 1. Simply minus 5 plus 5, 0, 0 minus 2, minus 2, and 0 minus 1, minus 1. Now, we try to understand the pictorial representation. So this is the A, lower bound, and B is the upper bound, and x is the point before the middle point, A plus B by 2. The opposite point will exist after the middle point. So x check is the opposite point in one-dimensional representation. Next, two-dimensional representation. So this is A1, A2, and B1 and B2. So this is the upper bound and this is the lower bound. This B1 will be A2. Sorry for the mistake. And this is the point P. So the opposite point will be P check. So it can be expanded to 3-dimensional up to n-dimensional based on our requirement. Now, incorporation of opposition-based learning in meta-heuristic basic philosophy. So there is two sections. One is opposition-based initialization, another is generation jumping, opposition-based generation jumping. So before going to that, so after inventing the opposition-based learning, it is first incorporated in differential evaluation and particle sum optimization, maximum case. Okay. So this is the example taken from the differential evaluation. So this is a basic phase, that is opposition-based initialization. So here, first we randomly initialize the population. Suppose there is n swarm, n search agent, we randomly initialize it using uniform distribution. Then we calculate the opposite population. So this is also n number of points. We merge them and select the n elite solutions. Then we start the algorithm. Next phase is generation jumping. So there is a probability, it is set generation jumping rate. So we randomly generate a number in the range 0, 1. And if that is less than the generation jumping rate, then we'll calculate that opposite solutions, then merge the opposite solutions and the original solutions, And then from that pool, we'll select n number of elite solutions. Otherwise, if that condition is violating, then we perform the basic D operation. Now, there are different types of OBL, but I am giving the name of some. First is quasi-OBL, generalized OBL, centroid OBL, rotation-based learning, and partial COBL. So these strategies are the modification of classical opposition-based learning. And one point here, that is rotation-based learning, it is not actually opposition-based learning. This is one learning strategy, but it inherently follows the mechanism of opposition-based learning. So that's why it is level grouped in that category. The partial COBL is developed by myself. It is recently published in IEEE Access. Now, quasi-OBL was proposed by Raina Mayan in 2007, and it was first incorporated in differential evolution algorithm. So I'm not going to details in the math stuff. The simple step is to calculate the midpoint. M equal to M plus N by 2. Suppose my lower bound is M and upper bound is N. M plus N by 2. This is the middle point. Now we have the original point. So if the original point is less than the middle point, midpoint, then Mj plus the quasi opposition point in jth direction or jth dimension, that is Mj plus y check j minus Mj into rand 0,1. Here rand 0,1 is the uniformly distributed random number in the range 0 to 1. If yj is not less than Mj, otherwise opposite condition, then y check j equal to y check j plus Mj minus y check j into rand 0,1. So this is the basic algorithm. I have written it in algorithmic representations. So simply that formula, it is written in a pseudocode. Okay, so that we can easily write the program. Next, so quasi-OBL, the graphical presentation, illustration. This is the A is the lower bound, B is the upper bound. So X here is the original point and X check is the opposite point. So what will be the place of opposition, quasi-opposition point? So it will be in the place between the middle point and the opposite point. So this is the two-dimensional representation and this is the 3D representation. So it can be used in multi-dimensional problem. Next is generalized OBL. It is developed by one. Let X be a solution in the current space X and X belongs to the range capital A, B. So A here is the lower bound and B is the upper bound. The new solution X star in the transform space X star is defined by X star equal to K into A plus B minus X. So what is the classical OBL? A plus B minus X. Here is generalized OBL. This is the difference is that K into A plus B minus X. So a weighted is given here. So the search space is transformed and then the opposite point is calculated. This point is known as generalized OBL. So this performed well, better than classical OBL. Next, first it was incorporated in opposition-based. That opposition-based learning scheme is used in enhancing the performance of particle sum optimizer. Then I have implemented in particle sum optimization, but in another way, that is particles p-based position. So in the first place, the first work used in the current position, I have implemented it in the p-based position, person-based positions. Next scheme is centroid opposition based learning. It is recently developed. It is use the concept of center of a mass. That is simple formula is the middle point is x1 plus x2 plus x3 plus xn divided by n. Now, if we extend it to the multi-dimensional, suppose d-dimensional or n-dimensional, d-dimensional, we have n number of population and d-dimensional solution. Then we can calculate the middle point mg equal to 1 by n summation I equal to 1 to n xij. That means we dimensionally we add it and divide it by n number of population. Now, finally, the opposite solution is calculated in that way. X check I equal to 2 into m minus xi. So the center point, it is multiplied by 2 minus xi. So the difference is that instead of subtraction from the addition of the space, subspace range, that is a plus b minus x, in place of a plus b, here 2 into m.
All the time.
So this centroid opposition based learning first incorporated in differential evolution algorithm, and next what I have incorporated this into algorithm, that is Giza pyramid construction algorithm in the Misr, Egypt, that Giza pyramids. So the construction of Giza pyramids, that using that philosophy, okay, that Giza pyramid construction algorithm is developed, and I have incorporated that COBC in that algorithm, and next I have incorporated in sine cosine algorithm. The formula, the sine cosine algorithm is developed by modeling using the formula sine and cosine. Now, another learning is rotation based learning. Now, rotation based learning, it is not the actual classification of opposition based learning, but it inherently implement the opposition. So first diagram A, so if K is the original point, N is the opposite. Here in the diagram B, K is the original point, P is the opposite point. So here one thing is incorporated, that is the phi, the deflection angle. Okay, by rotating, by increment or decrementing that angle, we can inherit the property of opposition. So this is the math stuff. I am not going to that. And we can, the deflection angle, it has to be set. So generally it is set to 180 degree. And that formula phi equal to phi naught into Gaussian normal distribution with 1 mean and sigma standard deviation. So generally standard deviation is set to 0.25 in initially. Okay. And next throughout the iteration, it is modified by that formula phi equal to phi naught into a normal distribution having 1 mean and sigma standard deviation. Now this is the basic algorithm to calculate the RBL. So first what we calculate, for we have d dimension and n number of population. So for j equal to 1 to d, we calculate the lower bound and upper bound dynamically. That means here the difference is that we have a fixed range. Suppose A and B fixed, but here Aj equal to minimum of xij. That means the populations covered, suppose this is the entire space, that door is the upper bound, this wall is the lower bound. Okay, so we can use that bound. Otherwise we can use a dynamic bound. That means we are the people in that room. So this is the range. Suppose in that chair one person last, and here is the first person. So I will be the lower bound and this person with the upper bound. So while we are moving across this space, that space will be changed. Lower bound and upper bound will be dynamically changed. So here we dynamically adjusted the lower bound, upper bound is equal to minimum for all I, X, I, J. So here X is the solution, the search agent, represented by search agent. Okay. Bj is the upper bound calculated dynamically, that is maximum for all I, X, I, J. Now the Cj, that center point, is calculated as Aj plus Bj by 2. And using the formula, we calculate the RBL. So rotation based differential evaluation. So we can observe that all the opposition based learning is generally used or tested in either differential evaluation algorithm or particle sum optimization algorithm. But there is a huge scope to implement in others algorithm. The second, the identification of Bayes relation through integrated study of gorilla tubes optimization and rotation based learning from MRI images. So this is my work. Okay, it is accepted in scientific reports of Nature. Recently, it is accepted. So I have used that rotation based learning scheme in gorilla tube optimizer, and then I use that algorithm to detect the lesion in breast. Now this is my partial OBL. Partial OBL, another scheme, but that is useful. First, it is incorporated in adaptive differential evaluation. Next work, I have used POBL in particle sum optimization in artificial neural network for medical data classification. So in multi-dimensional search space, a complete opposite point contains opposite values of original values in each dimension in OBL. In multi-dimensional space, the partial opposite point contains opposite number to the original numbers in some dimension. Try to understand the difference. Opposite classical OBL that calculate the opposite for each dimension. Okay, along the each dimension, along all the dimension, considering all the dimension. But partial OBL means we keep the original points in some dimensions, and in other dimension we use the opposite points. So that's why it is called partial OBL. Now this is the representation. Suppose Px check 1. So here 1 represent the order or degree of the partial opposition based point. So we have multiple degree that is equal to the dimension of the search space. So that is equal to, you can see x1, x check 2, x check 3 up to x check d. Now next column row, x check 1, x2. So here x2 is the original point. In one dimension, just we keep the original point, and rest of the dimension we use the opposite points. So now you can see that we can have d number of row if the dimension of the problem is d. So here that degree is 1 because we keep the original points in only one dimension. But that place can be changed, varied. Okay, we can have order of degree 2. In that case, we have to keep the original points in 2 dimensions. And rest of the dimension, we place the original opposite points. Now, for a numerical example, suppose x equal to -2, 1, d. This is a 3-dimensional point. In the search space of range -4, 9. That is where -4 is the lower bound, 9 is the upper bound, and 3 dimension, that range is same. Okay. So the opposite point of x check of x is 7, 4, -3. If we calculate the opposite point. So 7, 4, -3. Then what will be the partial opposite points considering degree 1? So that is -2. So just place 7, 4, -3 in each row. Then in the first row, first column, put the original point -2. In the second column row, change the 4 to 1. So 1 is the original point. In next row, last row, change -3 with the original point D.
How is the opposite point calculated? To 9 minus to 1 8 from minus to 1 8 7.
-4 plus 9 minus -2.
Okay.
Now another scope is that you can dynamically change the bound space. You can use dynamic space, search space. So this is developed by myself, this algorithm, and that is applied to sine cosine algorithm, blue whale optimization algorithm, and arithmetic optimization algorithm. So this is the pseudocode of the PCOBL calculation. So first, the X input is X, that is d-dimensional search points. The solution, its centroid opposition solution is, suppose, or you can take it simple opposite solution. Okay. Next, output will be P X check C. So dimension equal to D, that is equal to size of X, that it will extract the dimension. And for J1 to K, so K is the number of partial solution you want to consider. So there are D number of solution for degree 1. Yeah, but how many number partial? There is huge scope. Okay, but how many numbers you will get? You want to take. So that is the K. Okay, so K number of partial solution I want to use. So for J I equal to 1 to K. Now P X check I C equal to P X check C. So what is first we use a variable Px, okay, equal to the opposite points. Okay. Next we calculate the degree. We take assign the degree randomly. Okay. So maximum degree will be D minus 1. Why it is not D maximum degree? I will explain that. It is D minus 1. So rand 0,1 into D minus 1. Use the ceiling functions. So you will get a degree, random degree. Now for J equal to 1 to degree, you can calculate L equal to ceiling function D into rand 0,1. So how many opposite numbers you want to place original points actually? So Px check IL equal to XL. So L is the index of the position. Okay, so for J equal to 1 to degree, so degree is 3, we have to consider 3 index position. Okay, if 2 index. So accordingly that we'll calculate the index and put the original element in that particular index of the partial solution. So in that way we calculate the partial COBL, okay, or PCOBL. So next is how can we incorporate that in meta-heuristic algorithm. So simple philosophy, that is opposition based initialization first. So here we initialize the solution using COBL, centered opposition based learning mechanism. Okay. Then so while loop, so as per philosophy generation jumping, if rand 0,1 less than the generation jumping probability, then we compute the opposition based computing. Okay, employ the opposition based learning. So first calculate the COBL solutions and next calculate the PCOBL and then merge all original, centered base and partial base. Okay, and select the n number of solutions. Okay, so whatever sorting algorithm you can use. Okay, so you will take the base time complexity. Okay, you can consider algorithm. You can take quick sort algorithm. Okay, n log n base 2. Okay, so what we'll do first, we merge the corresponding fitness values of all the original centroid base points and partial centered base points, and we'll sort it in ascending order if the objective function is to be minimized, and then according indexing, and accordingly we arrange, merge the solutions and select the, after merging, select the solution in elite solutions based on the sorting. If the condition is violated, okay, then we'll simply perform the basic operations of the meta heuristics. So update the position of the individual using the operators of meta heuristic, evaluate the objective function for each individual, update the best solution, that is P equal to X star, and so forth. So this is else block contains the basic operations of the meta heuristic. So now PCUBL is designed to have a more effective exploration and exploitation ability in the search space than CUBL scheme. So we have mathematically established that fact and also experimentally proved it. Okay. So what is now exploration and exploitations? Exploration means global search. Okay. And exploitation means local search. So global search means we oscillate highly perturbation. That means if I jump it, I suppose jump 2 meters, high jump. Okay. And local search means intensification. Suppose I step 2 steps. I forwards 2 steps, move forwards 2 steps. So this is the local search. That means small perturbations. Now, why it is necessary to improve the performance of an algorithm? We need a trade-off between exploration and exploitation. Too much exploration will not help to improve the performance of the algorithm. On the other case, too much exploitation will not help. Suppose I have lost my pen in the middle position of that room, and I am moving here using small steps. I will never reach to that place. So highly exploitation is not working. On the other way, suppose the pencil is here and I jump 2 meters or 3 meters. Okay, I will not reach to that pen. Okay, so high exploration and higher exploitations is not good. Okay, we need a trade-off between these two things. Naturally, in case of meta heuristics, during the beginning of the search algorithm, we need exploration. During the end of the algorithm, we need exploitation. So first we randomly search, that is high perturbation. Then whatever we have, we fine-tune that solution so that we reach to the global optima. So like POBL, many PCUBL points with different degrees can be generated for an original point. Now, what's the number? So that is calculated. So for all degrees m equal to 1 to d, we have d number of d dimension. So we have d degree of partial PCUBL. The total number of partial centroid opposite solutions can be generated from the centroid opposite solutions of an original solution is equal to summation j equal to 1 to d minus 1 cj equal to 2d minus 2. Now here one point is noted that in the mathematical expression d minus 1. Okay, so the partial solution of order d is nothing but the original solution. Okay, because you consider all the dimension and put the original points of the opposite solution, so it becomes the original points. Okay, so actual PCUBL solution is summation g equal to 1 to d minus 1 cj equal to d minus 2. So that is, if we place it, derive it, so it will be 2d minus 1. Okay, as combination combinatorics, that is CDD, that is equal to 1 is the number of d degree partial opposite solution, nothing but the original solutions. Okay, so therefore we have total number of opposite solutions we have that is a 2 to the power d minus 1. In case of opposite solutions, we have only 1. But here, 2 to the power d minus 1. So this is the huge number of solutions we can evaluate. We can take this. Okay. Now, another disadvantage is that if you consider all the solutions 2 to the power d minus 1, your computational time will be increased. Okay, so we have to select the number of opposite solutions, that is the degree or the number of opposite solutions in an efficient way. So this is the scope of work here.
How that thing will be chosen.
Yes. So if anybody want to work in that area, that is a selection of degree as well as the number of opposition based solutions. So any mathematical formula that can be deterministic or adaptive. Okay, adaptive means throughout the iterations, it can calculate by itself. Okay, so this is the open problem. Now, how exploration is maintained and exploitation. So I have mathematically explained here. Suppose I have a point, original point x1, x2, x3, three-dimensional point, and its opposite point x check 1, x check 2, x check 3. Now, the opposite points of degree 1, p x check 1, 1, that is equal to x1, the original points in first dimension. That subscript 1 means the first solution, partial. So x1, x check 2, and x check 3. Okay. So similar way, px check 1, 2, the second dimension and the third dimension. Okay. Now we calculate the Euclidean distance. So dx comma x check equal to square root of x1 minus x check 1 whole square plus x2 minus x2 check whole square plus x3 minus x3 check whole square. So this is the Euclidean distance. So x check here the opposite points. Okay.
One, except two, except three, these are all are opposite points.
The
Sorry.
points of opposite solution. Okay. Three-dimensional problem.
Yeah.
Okay.
For three dimensions.
Next. Now, if I consider the first solution, so this is distance Euclidean distance x square root of x1 minus x1 check whole square plus x2 check minus x2 minus x2 check whole square plus x3 minus x3 check whole square. So now for that solution, first pupil solution, you can see that is x1 equal to x1 check. So naturally, that is the first term will be vanished. Okay. Now that comes to x2 minus x2 check square plus x3 minus x3 check square. So this is that distance is obviously less than the opposite point distance from the original point. Okay. So if we calculate in that way for all the solutions, we can have that distance of x and p x check 1 that is greater than distance of x comma p x check 2, that is a degree. Okay. And dx comma p x check d minus 1 degree. So as the order of the partial opposite points is increased, the distance for the original point is decreased. So if you increase the degree from the original point, its distance will be decreased. So distance is decreased means
The specific area, small area.
so yes, so this is local search. So if you the partial centroid opposite points with lower order help in exploration. Okay. As the degree is high, the distance is minimum. Okay, that means distance minimum means exploitation. So higher degree means exploitation. Lower degree means exploration. Okay. Now, what is your objective? We need our main objective. Our main objective is to balance between exploration and exploitation. So in order to do that, we have to select the degree in an intelligent way. Yes or no? Okay. So we have to select the degree. On the other case, we have to select also the number of opposite solutions. So in my work, I fixed the number of opposite solutions 3, but I selected the degree randomly. Okay. So anybody if want to do the works on that area, his task is to use a formula by which that the degree can be selected in an efficient way, so that the balance between exploration and exploitation can be done in a better way. Okay. Now, if you want to publish a paper, okay, so you have to give the evidence that whether your proposal is providing good exploration or good balance between exploration and exploitation. This is the mathematical way. So using that formula, you can calculate exploration and exploitation and trade-off. How to do that? So first calculate the median, okay, of the solutions, and then subtract each individual solutions for each dimension. So you will get deep J of T, that means T time, and you sum all that for D dimension and make it average. Okay, so deep T, that is deep is divergence, okay, or diversity. So next, so XPL, that is the exploration, percentage of exploration, that is deep T by D max. So there is 100 iteration. You will calculate deep for all iterations. After completion of that, you can get the maximum. Okay, and then you can make it ratio and multiply it with 100. You will get the percentage exploration. And now exploitation, that is XPT percentage. So this is deep T minus D max divided by D max into 100. So this is the calculation of exploration and exploitation. But now the trade-off. So till now there was no formula to how to calculate the trade-off. So I have used the geometric mean to calculate the trade-off between exploration and exploitation. So that is the geometric mean TO percent, that is the trade-off percentage, equal to the square root of XPL percentage T into XPT percentage. So if it is suppose exploration and exploitation, suppose if it is perfect balance, it will value gives nearly about 50%. Okay, around that value. Okay, so if any of them is high, suppose if your algorithm is giving 90% exploration, so obviously the exploitation will be minimum, and in that case your geometric mean, the trade-off will be any of two, that is the exploration or exploitation, any of these two is getting high, then that geometric mean value will be very low. Clear? So in that way, you can calculate that whether it is giving the perfect, the balance between exploration or exploitation. So you can use that mathematical formula. So this is a well proof. If you want to publish a paper, so first you have developed suppose mechanism. So you have to incorporate it. You have to test that meta-heuristic algorithm on benchmark problem. Okay, there are CEC series benchmark problem and engineering design problem. So I have used tested that PCOBL with meta heuristic in spacecraft design problem, 2 spacecraft design problem optimization problem, and 2 antenna design problem, real life problem. Okay, and test its significance, whether its performance is significant in the real life scenario or not. So the source code is available in GitHub, that is github.com, taposi-iml PCOBL. The source code along with the paper is available. Okay, if anybody can want to incorporate that PCOBL strategy, he can incorporate in any other meta heuristic algorithms. So now basic fundamental things, how to incorporate. The simple thing is that opposition-based initialization, 2-phase opposition-based initialization and generation jumping, opposition-based generation jumping. So first initialize your solutions, then calculate the fitness, calculate the opposite solutions, calculate the fitness of the opposite solutions, and next merge that fitness, sorting it. Based on that sorting, take the n-based elite solutions. And next, you have transition criteria for your meta heuristic, whether it is iterations or some threshold value error, then set the jumping rate probability PJG, generate a random number in the range 0 to 1, uniformly distributed random number, and check it whether it is less than PJG. If it is less than, then perform the opposition-based learning, incorporate the opposition-based scheme. Otherwise, do the basic operations of meta heuristics. Okay. So first, inside the if block, if condition is true, we perform the generation jumping. Calculate the OBL solutions, Xi of each search agent, calculate the fitness of OBL solutions, and then select the elite n solution from the set X and X. That is the original solutions and the opposite solutions. So this is the basic philosophy. If you follow this mechanism, you can build your own operation-based meta heuristics algorithm. Okay. So these are the reference. The good references are there. Global Optimization Algorithms, Theory and Applications. It is a very good book. It is online available. Okay. If you want to do research on global optimizations, or if you want to apply it in any kind of optimization in machine learning or real-time problem, whether it is electronics, electrical, or civil, mechanical, so you can take help from this book. Okay. And next reference are the opposition-based learning literatures. So these are the reference. Thank you very much. If any questions, please. Please.
In the online mode, does anybody have any question? They can unmute yourself. Anybody having any questions? So,
Sir, I have a question.
Yes, please.
The question is that you are here in your PPT, you have told that it is the elite solution.
Yes, yes.
So why may I know that answer that why that thing is known as the elite solution instead of solution?
Okay. So you are merging the solutions first along with the fitness. Okay. Suppose you have n number of solutions, n number of opposite solutions, you have n plus n, that is 2n number of solutions. Okay, fitness. So that is in a random order. Okay. So after ascending it, sorting it in ascending order, if your problem is minimization, so you will definitely sort it in ascending order. Okay. So you will get arranged manner. Okay. So pick up from first 10 elements. So these are the elite, 10 elite.
10 elite. When we are picking up from the 10 solutions, it's called 10.
10 set of elite elements. That means best solutions.
Best set of
So
set of-
you are going with n number of solutions you need. Okay. Yeah.
So obviously the allied things are always available in the beginning. So we can take the
After,
initial
yeah, whatever algorithm you use. Okay. Okay, ascending order, we will select ascending order. Okay, so if your problem is minimization problem,
Yes.
Okay.
Minimization problem.
minimization problem. So actually not minimization problem. Suppose, try to understand the philosophy. So particles, suppose particle sum optimization. By default, it minimizes the opposition objective function.
It is a minimization type problem.
Okay, now if it is inherently minimize the objective function, then you have to use the ascending order. If the algorithm use the maximization inherently, okay, so you have to use descending order. Got my point? Okay, now if particle sum optimization by default inherently minimizes, that means you can also solve maximization problem using particle sum optimization. Just you have to change the objective function. So
I distribution used for testing your result, like degree you are taking.
okay, the basic philosophy is according to CEC standard norms. So it is 10D, 30D, 50D, 100D. So generally I use 30 dimension, 50 dimension, and 100 dimension. And there are benchmark functions in the series. That is, suppose for CEC 2013, there are 28 benchmark functions. So you have to run each functions for 30 dimensions. You have to run for each functions for 50 dimension. You have to run each functions for 100 dimensions. So when dimension is increased, then it gets more time. So you need the computational power to conduct that kind of experiment. Any other queries?
Like any other queries, I like you are very well defined everything. So right now we need to think about the whatever the future scope is available. We need to think about that.
Yeah.
So in future and being that.
So there is a lot of future work. So PCOBL, that is developed by myself. So this is the philosophy. Okay. So using that philosophy, you can design your own OBL mechanism.
I will still ask you one thing. My question is not too deep into the topic, but the question is very simple. And mostly, from my experience of computer science research, what I have seen, we design many algorithms, but which algorithm will perform the best, that 99% of the time depends on the input. The input determines which algorithm will perform the best. Like, but you are also comparing between algorithms. In this case, this will perform better, this case, this will perform better. Is there any way to dynamically determine that which algorithm will perform the best?
Okay. So there is a way. First thing is that there is a philosophy, a theory, that is no free lunch theorem. That means one algorithm can perform better than other for a class of problem.
Absolutely.
Okay. On the other way, it may not perform for other problem. Okay, that reverse thing happen. The class, suppose A algorithm and algorithm B. A algorithm perform better than B for a particular class of problem, whereas another class of problem, A algorithm cannot beat B algorithm. B performs better than A. So this is no freelance theorems. So that's why when we face the problem, that is that particular algorithm A cannot perform well. Okay, that means some algorithms, new algorithms come with improvement. Okay, give better performance. Okay, now that it is observed that that algorithm also, that is well proved, that is efficient than others, previous algorithms. But when a new problem comes, then we observe that it fails because there is diversity problem, lack of diversity. So meta-heuristic algorithms depend on the diversity. Okay, so it gets lack of diversity, it gets trapped in the local optima, because when the problem is changed, the error surface or the problem landscape is changed, and according to that, algorithm may get trapped in the local optima. So in that case, we need to develop that, how to get out from the trap. So we have to move it, get it out from the trap. So that's why we modify the algorithm. Okay, now come to the second point of that answer question. So there is another philosophy, that is hyper heuristics. Hyper heuristics design a heuristics algorithm, meta heuristic. So genetic programming, grammatical evolutions, using grammatical evolution genetic programming, there is a lot of research work has been conducted. Okay, so to find the optimal algorithm. Okay, it will select for design the algorithm. So it is called hyper heuristics. Any other questions?
Thank you,
Okay,
sir,
thank you very much.
for the presentation. Now I'd like to call Mrs. Sir to kindly present the token of appreciation.
You can move the camera.
Yes, sir, yes, sir. So, pigment visibility can you make it here? Because I need to get it from here only. Okay, taken? Okay,
Yes.
okay.
Yes,
Thank you. Dr. Vijay Ketan Panigree, sir, you are here, sir?
Yes, I am here. I am well here.
Oh,
Yeah.
okay, sir. Okay. And thank you so much, Tapasai, sir. It's a very wonderful presentation and very informative. And mathematically, it's very strong and you explain it very easy way. Thank you for that. Now we are having with us Dr. Vijay Ketan Panigree, sir, from IIT Delhi. Before sir will start his speech, I need to introduce him.
Oh, no need to introduction. Let me start because I am at 11:30.
Okay, sir. Okay, sir. Okay, sir. Now you can continue, sir. No issue.
Yeah.
Okay. You can share your screen, sir.
Yeah, I'm saying. Is it visible to all of you?
Yes.
Yes,
Yes,
sir.
sir.
It's visible.
And the slides are moving.
Sir, yes,
Yes.
perfectly, sir.
Yes, sir.
So let me start. Thank you.
Thank you, sir.
For the opportunity. Thanks, all of you, the organizers. And I'll talk about the swarm intelligence or computational intelligence because already Professor Somen, I have already discussed about evolutionary algorithm, swarm intelligence algorithm. So I'll talk of the hybridization of these algorithm with the other computational intelligence tools. So if you look into the computational intelligence tools, it's very clear. The initial tool which was developed is the basic neural network. So when we talk about the neural network, these are based on the learning process. And when I'm talking of the learning process, it is the learning process of the brain, which is a connectionist model. And every learning process is a gradually evolving process because you can't learn on a one iteration. You can't learn immediately or instantly. So every neural network is basically depends on the adaptation capability of the your neurons. Okay, how it can adapt to the situation. So that's why if you look into all these neural network, we have the very initial the swallow network that is multi-layer perceptron network, or you can go for RBF network or any type of neural network. Then gradually people come for the support vector machine, extreme learning machine, a random vector functional link network. So like there are different structures of the neural network. But if the basic idea of this neural network is, it is a connection model between the input and output. We want to map the input and output. Application, a lot of application when you want for the forecasting, for the regression application, for the classification, as well as it has also a tremendous application in the system identification, because there are some systems where I know only the input, I know only the output, but I don't know any mathematical relationship which exists. The system cannot be modeled. Any system, being an engineer, everybody know, any system can be modeled by a set of differential equation, algebraic equation, whether linear or non-linear. So if you have a model of the equation, you give the input, you can find out the output. You can find out the different states of the system. But when I don't know about the system, it's black box. There are inputs and there are outputs. So we need a mapping. So this mapping, of course, we do in the very early stage, class 3 or class 4, but people don't know how to. For example, if I will take a simple time series, mathematical time series, 2, 4, 6, then I will put 2 dash. So those 2 dash is nothing. You have to predict what are those 2 numbers in a time series. So definitely a class 4 student will happily tell you, okay, 2, 4, 6, 8, 10. So this is a linear, very simple. But he can't tell if I'm putting a time series 1, 3, 9 dash dash, is not able to tell 16 and 25. Maybe class 7, class 8 student can tell. But whenever there is no relationship, whether linear or non-linear, no fixed relationship between the patterns. So we need in those cases the neural network to learn this system. So that's why my point here is, I know many of you are working on the neural network, the swallow network, the deep network, the CNN, and all these type of CNN. I'm not going into that. But that is one vertical of the computational intelligence having tremendous application in science, engineering, and even if the management for the decision making also. Then the second one, thanks to Professor Laptizadeh, 1965 developed this fuzzy logic, which based on the perception. It is a perception, it is a high level human cognition. I can give you a simple example to understand this fuzzy, the concept, because we always talk fuzzy means control, a fuzzy control. Okay, so let us, I am a driver, I am driving the car. So when I'm driving the car, I am controlling the angle of the steering wheel, I am controlling the acceleration, how much acceleration I will put. So, and this system is a feedback system. This is a closed loop control system, because my steering wheel torque by an angle theta, and the acceleration, tracing of the acceleration by an amount del x is depend on the feedback, what I am getting, whether there is a vehicle outside or a vehicle is nearer to me or something like that. So it's a complete closed loop system. But remember, suppose I want to park my car in between 2 already parked cars. So there are 2 cars which are parked on. So I am never having a tape. I am measuring the distance between the 2 already parked cars. It is 2.5 meter. The length of my car is 1.2 meter. Yes, I can park it. It is a decision. Then I calculate S equal to UT plus half AT square. Nobody does it. So please try to understand here. The control is only based on the perception. I look outside. Yes, there is enough space. So when that linguistic variable comes to my mind, a fuzzy variable, yes, enough space, then I park my car. Accordingly, I adjust theta and I adjust acceleration. So this is a very simple way of fuzzy logic. So it has, whenever there is uncertainty, whenever there is the system you want to identify, there are a lot of uncertainty and there is no crisp measurements are available. Based on that, you can tell your fuzzy logic. So which has tremendous application in various engineering areas. Then already discussed by Professor Somen, the evolutionary algorithm. It is the Darwin's theory of the survival of the fittest. What happens in evolutionary algorithm? I have a set of solution. I am generating a new set of solution from the old set of solution by means of the crossover, which is a genetical crossover to generate a set of offspring from a set of parents. Okay. So that is the evolutionary algorithm, but maybe genetic algorithm and others. But gradually people have also tried many swarm intelligence algorithm based on the collective behavior of n number of agents. Okay. The main idea is to have a better exploration, that is the global search ability, and a better exploitation, the local search ability. So combining this, we have many algorithms, but all these algorithms are stochastic algorithm. It's a stochastic process. Okay, there is no fixed rule how this algorithm will evolve. Like your Newton-Raphson algorithm, if I have a solution x0, the next solution is x0 plus del x. I know the increment and I know the direction of the increment. So the amount of the increment, the direction of the increment, and the proceed of the Newton-Raphson method is as per the based on the information of the gradient, which is the mathematics slope dy by dx. But in a stochastic algorithm, there is no way, there nothing. I generate a new set of solution from the old set of solution based on what is happening in evolutionary process, what is happening in a swarm intelligence process, how I learn how to generate a new solution from an old solution. So these are the three basic verticals of the computational intelligence where we look into all this. But what I exactly want to tell now, this is a neural network structure. I'm not going into that. At least in a neural network, people know how many inputs are there. Your input pattern is fixed, whether there are 3 input, 4 input, 5 input, 10 input. Output is fixed, whether it is a single or multiple. But what you do not know is how many number of hidden layers you will take. The classic is minimum at least 1 hidden layer, and the number of neuron in the hidden layer must be equal or greater than the number of the input. But how will you guarantee the particular structure of the neural network which you are adopting for your application is the optimal structure of the neural network? So why I am telling this? Because I want to link the neural network to evolutionary algorithm. Somebody may expert in neural network, somebody may expert in optimization. So here I try or I want to give you some idea how you can optimize or you can evolve the structure of the neural network so that that structure is an optimal structure for your regression problem or classification problem. So that's exactly what I want to tell to you. So again, now what is unknown? What you want to optimize? You want to optimize how many number of hidden layers will be there. You want to optimize how many neurons will be in each hidden layer, because you don't have to play with the number of input and number of output. That pattern is almost fixed. But in some cases, you can also tweak how many number of input do you want for a better classification problem. For example, if you have n number of features for a classification problem, you have signal, ECG signal, EEG signal, vibration signal, whatever. I extract the features, either it is the time domain feature, either it is the frequency domain feature, or it is the time frequency domain feature by applying various, you may take the RMS value, kurtosis, skewness, you may take the frequency domain feature, different frequency band, what is the energy, what is the entropy. So a lot of features you take, but you don't know what are the optimal features, what are the best features for your classification problem. So you see, I'm giving you the problem, you will find the solution, because that is the research. So in that particular case, for example, if I want to classify between a cow and goat, and in this case, I'm taking the feature as the number of legs, then it is a redundant feature. Cow has 4 legs and goat has 4 legs. So that may not be a useful feature. Unnecessarily, it will increase the number of the features in the input layer and the computational burden will increase. So if you want, what are the optimal number of features also, you can also apply your optimization. Question is, how to apply your optimization algorithm to evolve the neural network during training process also. What happens? Because the classical learning is you give the first input, have the random weights, you will get an output y1, you have a target t1. So t1 minus y1 is the error. You want to minimize the error. In class 12, we know the minimization of error is dE with respect to dW, the number of weights, because the weights are not perfect. That's why there is error. So based on the error, you update the weight. That is a backpropagation learning and gradient based learning, because I am dependent on dy by dw. Okay. So why we are thinking the error surface is a unimodal surface having only one minima. The error surface may have multiple minima. So in that case also, rather than adopting the gradient based learning for the backpropagation of the error to update the weight, you can evolve the weights also. So please try to understand, I have given you multiple problem domain where your optimization algorithm, I don't bother, because just somebody has asked which algorithm is better, whether PSO is better, differential evolution is better, ant colony is better, or something better. Yes, the course answer was the no free lunch theorem. So you have to look into your problem. Look into your problem and find out a particular algorithm for the optimization of the structure of the neural network, the learning of the neural network. We call it evolvable neural network, because the structure will evolve as the learning process increases. Now the question is, every evolutionary algorithm is have an objective function. So what is your objective function in this case? The objective function is minimization of the error. The objective function is maximization of the accuracy. Same thing. If I can minimize the error, I can maximize the accuracy. But remember, there is no mathematical function. Like Professor Somen has already told, there are test bench function, CEC test bench function, mathematical function. You know the number of inputs and everything. But here I don't have a mathematical function to optimize. I want what should be the structure of the neural network? I have 1000 patterns, 3 input, 1 output, 1000 pattern. I want to learn those patterns. Then I have to test it with another 500 patterns to see whether my neural network is giving highest classification accuracy or not. But there is no mathematics. So what you'll do, please try to understand. I have 2 sub-programs. One program is the neural network program. Another program is your evolutionary algorithm program. So what is the evolutionary algorithm program does? Either you have a particle, you have an ant, you have a vector in differential evolution, you have a chromosome in GA. So that represents the structure of the neural network. Suppose I want to optimize the number of hidden layer. I want to optimize the number of neurons. So what I'll do, there are 2 inputs. One input is the number of hidden layer. Let us, I have 1 hidden layer to 5 hidden layer. So generate a random number between 1 to 5, let it is 2. Generate a random number between 4 to 10, that is the number of neuron, it comes 7. So the first chromosome, the first particle will create a neural network. It will pass to the neural network program. In a random neural network is created where there are 2 hidden layers. Each hidden layer is having 7 neurons. All the patterns will be tested. And finally, the output is what is the classification accuracy. That is the mathematical evolution of chromosome 1 or particle 1. You do that for all the particle in the swarm size. You do it for all the chromosome in the genetic algorithm. Then you'll find what is the best, global best, local best, then you evolve. So my point is, in the next iteration, this algorithm is evolved. So many researchers have that idea, how I will optimize the neural network structure where for the accuracy, there is no mathematical description, no mathematical function. So it need not be always a mathematical function. It may be another sub-program. So there you are linking 2 sub-programs. One program is creating a random structure of the neural network. That structure is passed to the neural network problem. Then the neural network will learn as per you are getting your RMSE or whatever that is objective. You will go to the classification accuracy or the error, minimization of the error, then that is the objective function. So this is the way how I can evolve the neural network structure. Even there is another important thing also. You can evolve the transfer function. You don't know which transfer function will be better, whether it is a linear, it is a tan hyperbolic, or it is a ReLU function or whatever. So see that creates the search space very large. So many large search space. So you may need the evolutionary algorithm for that particular purpose. So that's why it can be achieved in a traditional way. In a traditional way, you can achieve the structure. Just you start from a small sapling. Okay, 1 layer, 4 neurons, do it, increase to 5 neurons, 6 neurons, 10 neurons, go on adding another layer, increase, go on. So that is the way you can do. So this is the way you can go on increasing the structure till better accuracy is obtained. That is the constructive method. Or you can start from a larger network, go on pruning. You can go by the pruning method. So these are the way. Similarly, you can also tune your learning rate. So these are the different aspects how we can train or the neural network or how we can classify. So that's why the evolution of the network topology is basically either you can evolve the transfer function, you can evolve the topology, you can evolve everything. So now the structure increases. For example, I'm just putting an example. I want to evolve the structure. So I have to decide what is the minimum number of hidden layer and what is the maximum number of hidden layer. So you may have 1 to 7 or 10. So maximum. You don't want to go to the deep one. So 1 to 10. Then number of neuron, 4 to 10. Number of transfer function, you can just code unipolar sigmoid is 1, bipolar sigmoid is 2, hyperbolic tangent 3. So you generate a random number between 1 to 8. So a neural network will be created with, okay, let us 3 hidden layer, each hidden layer having 8 neurons, and the transfer function is sigmoid. Another chromosome 2 or particle 2, it may be 4 hidden layer, 8 neurons, heaviside transfer function. So everything is a random search. It goes on searching. So this is the way how I can evolve my neural network. So these are basically the single objective optimization, because your objective is minimization of error or maximization of accuracy. People also can work on here and the looking again the application problem, the multi-objective optimization. When I'm talking of the multi-objective optimization, there are 2 objectives and both the objectives are moving in the opposite direction. Okay. One classic example, generally we power system people do, we want to minimize the power cost, power production cost. If you want to minimize the power production cost, then you have to burn the low quality coal, so the emission will increase. And vice versa. If you will, power production cost will increase by taking high quality coal, then the emission will decrease. But we want low emission, low cost. It's difficult. I want to invest in the market, okay, with low risk and high return. It's not possible. We want to put sensors in a sensor network with minimum cost, minimum number of nodes, but high coverage. Not possible. So whenever there are conflicting objective, two conflicting objective, you may go for multi-objective optimization and Pareto based optimization or Pareto dominant approach. So in that case, now you see, even if look into the neural network structure I am getting. If you see in all the three structures, the 2 input, 1 output, I may have a very simple structure. So if I have a very simple structure, the generalization capability of the neural network may not be good. The error will be more or efficiency will be less. You may have a complicated structure, more number of neurons and highly, it can map the nonlinear function. So in that case, the error will minimum, the complexity is high. That means the efficiency is high, but the computational burden is high. So if there are two objectives, one objective is the accuracy, you want to maximize it, or you want to minimize the error, and simultaneously you want minimum computational time, minimum burden, and immediately you want action. Because that's why I have told you, you have to look into the problem which you are looking for. If your problem is a regression problem, it is a forecasting problem, I have enough time, I'm doing it for tomorrow, it is a planning problem. But if it is a control problem, you have to take the control action based on the inputs, and immediately that control action will fire something, or it will take immediate step to make the system stable or something like that. Then in that case, time complexity is very, very important. Accuracy is not important. So look into which is important for you, whether it accuracy is important or the time complexity, the time of computation is, because those who are apply control, neural network for the control purpose, I have to take the control action within a minimum stipulated time. Otherwise, my system will become unstable. So that's why you need a compromise solution looking into your problem. So have a multi-objective optimization, find out the compromised neural network for your application by applying the multi-objective. So I have just opened some way to you where you can, if you are expert in evolutionary algorithm, fantastic, you can apply this to evolving the neural network structure for prediction problem, for regression problem, for classification problem, for control problem, and you can go to it. Even if I'll just put one highlight here. Suppose you want to forecast. If you want to forecast, the forecasting accuracy should be high. But when you are exactly pointing to a forecast, tomorrow at 10 a.m. the rain will be 20 mm. So instead of 20 mm, why you are point forecast? You make a band forecast, narrow band. Okay, 19 mm to 21 mm. But I can forecast very confidently. Yes, tomorrow there will be a rain, but the rain will be between 2 mm to 30 mm. My band, forecast band is very large. So I want to narrow the forecasting band with a high confidence level. So these are the some problem where you can apply your multi-objective optimization to find out a better solution or compromise solution, looking into, again, I'm telling, your application domain. Same thing can be done for the decision tree also. The lower is the tree, the less will be the computational time. This has high computational time. So you have a trade-off between these two, and you can find which solution is selected. Because you are the best programmer, you know the programming, etc. You can apply all those to your application. Now, same thing in the fuzzy logic. When I do apply fuzzy logic for the control problem, or I do fuzzy logic for any of the problem, I have to fuzzify the inputs. So when you fuzzify the input, there are different transfer functions, the fuzzy functions, whether membership function. The member, because fuzzy is having a membership function. In crisp set theory, either the belongingness to the set is 0 or 1. You don't have anything 0 or 1. But in fuzzy, you have a belongingness. That means the particular input may be to the set 1 belong 80% to set 2 20%. So the membership function we assign. Like if you have a suppose cold and warm, you can see the cold or warm maybe up to 15 degree, 100% cold. But as the temperature increases from 15 to 30, then cold membership becomes 0, warm membership rises. And this warm up to 40 degree, it becomes warm. Then after that, up to 50, it becomes hot. So you have a membership function. Now the question is, why it is a trapezoidal membership function? It may be a Gaussian. It may be a triangular. It may be a symmetric triangular. It may be unsymmetric triangular. I don't know which one is the best. So always I try to give you that idea. Okay, you know the optimization algorithm and the traditional search algorithm, how we can apply the traditional search algorithm to this particular problem. That is the main idea. You can do that. So I can optimize, I can find out the best membership function for my application. So Again, what is the input? If it is a triangular membership function, I know the breadth, okay, and the vertices. So every membership function having 3 inputs, okay, vertices and breadth. Symmetric, that's why it will cover. If it is a symmetrical, only you want 1. That means among the vertices plus del x minus del x. But if it is unsymmetrical, you have to take 3 inputs. So every membership function, if it is a trapezoidal, it has again 4 inputs, 2 endpoints, 2 middle point. If it is a Gaussian, you know what is the spread. Okay, so and what is the center. So that's why depending on your membership function, those are the variable which will define the membership function is unknown, and that will be a part of your particle or chromosome or vector or ant or bee or whatever, maybe your algorithm. So that's why this is the way where I can utilize my algorithm, whether it is a genetic algorithm or PSO or differential evolution or ant colony algorithm or any of the algorithm, to find out the solution. Okay, so this is one way of doing. Just now, perhaps I was not present in the very beginning. Professor Somen has discussed about the PSO. In PSO, you will find 2 parameters. One is C1, another is the C2. C1 is a parameter which basically looks upon the self-learning, the self-confidence. And C2 is a parameter which looks upon the learning from the global leader, the learning from the leader, that is social interaction. So if I have the 2 components C1 and C2, and every algorithm is dependent on the tuning of the parameter, how you are tuning the parameter to suit in the application. That's why again the question is, with no free lunch theorem, there is another important aspect is how you are tuning the parameters of your evolutionary algorithm or swarm intelligence algorithm so that the algorithm will have a better exploration and better exploitation. So that's why if you look into the PSO, the initial paper C1 and C2 are 2.1, 2.1. And Maurice Clark, they told that this phi1 and phi2 or whatever, they must be greater than or equal to 4.2. So these are the initial paper, but gradually there are a lot of modification. So the question is how to select C1 and C2, when C1 will be high and when C2 will be high. So that's why the very basic what we observe in our day-to-day life. If the particle is starting to learn, if a kid is starting to learn in class 1 and nursery, so I leave him or leave her to learn on his own. So C1 must be high at the initial period. As the learning process goes on, then I will put on some competition. Then C2 will be high. Okay, maybe in class 10, class 11 for the competition purpose to crack all these competitive exams. So that is the beauty, that C1 must be high initially, C2 low, C2 gradually increases and C1 decreases. So that looking into that, can I adopt these parameters C1 and C2 of the PSO using the fuzzy? So I have already told you applying PSO in fuzzy and neural network. Now this is the reverse thing. So see, when I'm doing this, I have the membership function. So what is the membership function? In the membership function, I am only counting the iteration and I'm counting the diversity. So for example, rule 1, if the iteration is low, that means you are starting, and diversity is low, that means all the particles are narrow. That means they are not learning from the global. So in that case, what you do? Don't give C2 very high value, because all particles are clamped together at one place. The global and local are at the same. Mera topper jo hai, unka mark 60 and average mark is also around 58. So all are nearly equal. So that's why you look into the diversity. The diversity. So if iteration is low and diversity is low, then the rule is the C1 is high, C2 is low. Similarly, iteration is low, diversity is medium. You can give C1 medium and C2 medium. But high iteration, diversity is high. So in that case, you give C2 high and C1 is low. So this is the FIS, fuzzy inference system, the rule. According to the rule, you update your value of C1 and C2. And there are many multiple papers you can find out where the parameters are updated using all those algorithms. Okay, so whether the parameter of the differential evolutionary algorithm, BAT algorithm, or any algorithm, you can update by using the fuzzy logic. So these are the some aspects where you can mix up the hybrid algorithm. You can develop your hybrid algorithm. Okay, whether it is a neural network or fuzzy logic or your any of the evolutionary or swarm intelligence algorithm, you can help each other. So we have done this for the EEG. I'm just telling one application, the EEG application. So in EEG, we are obtaining signals. So either it is a 32 electrode or 64 electrode or 128 electrode. But when you are doing this EEG analysis, please try to understand you have to take the help of a doctor. So when you are taking the help of a doctor, you have to decide what is exactly your ambition, what exactly you want to do, whether it is a epileptic seizure detection, or it is mental cognitive task identification, or it is the sleep disorder detection, or something. So in that case, they will tell you, out of all these electrodes, a certain portion of brain, those electrodes are very important. So only you take those signals. Now coming to this, once you take the signal, now you will look into all these signal, and by looking into the signal, a doctor may tell if there is some problem or not. But for an engineer, these are just I look as a noise. So what you do here, once I got a signal, whether it is a ECG or EEG or vibration signal of a motor or anything, then we apply certain signal processing technique. So those signal processing technique may be the frequency domain technique, Fourier transform, maybe short-time Fourier transform, maybe wavelet transform, maybe wavelet packet transform. So what exactly we are doing here? In all these signal, we are applying a wavelet packet. So wavelet is a multi-resolution filter bank. It's just like I have a muddy water from a pond, then I apply it through a pebble layer, then sand layer, so that different particle will be filtered. So by applying the signal through different filter banks in wavelet analysis, I got the information of the content of the signal or the strength of the signal in particular frequency band. For example, 0 to 100 hertz, 100 to 200 hertz, or if it is a EEG, you have alpha band, beta band, gamma band, or something like that, because you are the expert. If you know what is your frequency of interest, accordingly, you can design all these filters. So the main idea, just I want to give you, with these filters, you can find out what are the different frequency components present. And based on those frequency components, you can find the kurtosis, you can find the energy, you can find the entropy. So those are the features. So once you extract the feature, those are time frequency domain features extracted from the signal to identify whether there is an abnormality or not, because it is a classification problem. And there are 4 classes you can see: normal, pre-ictal, ictal, interictal. Many people have the only 2 classes, whether there is a defect or no defect. So that's why these are the something you can do on that. So the idea is signal, feature extraction, then you do the classification. So by doing this classification, we do the lambda fold cross validation and all this classification. So 2 data set we have used here. One data set is University of Bonn data set. Those people are working on this. They work on this. There are different data set. Another data set is our own because we do it with a neurology and sleep center in Hotchkiss near IIT Delhi. So because you can find many papers on this particular one, and if anybody is interested, we can provide the data set to you. It is available, done by one of our student, Piyush Swami. So on this, now you can see the coefficient, different wavelet, the coefficient, you can see it is very difficult to classify. If you look into this particular range where my cursor is, this is just give me a minute, just a minute, one urgent call. Sorry. Okay, so in that case, their classification accuracy is very, very because all these features you can see they are overlapped with each other. So you need certain algorithm to find out this particular one. Okay, so that's why I have just in this diagram we have shown you how the features are scattered. Some features may be very distinct, but some features are overlapping with each other. And you can apply your any classification. Perhaps here we have done the support vector machine classification, and we do the lambda fold cross validation or k-fold cross validation for this particular purpose. Okay, so I'm not going into the detailed result, but this is the main idea, and we have optimized here also, because you see the feature. We have taken energy 14 feature, entropy, RMS, mean value, standard deviation, maximum peak, kurtosis, skewness, all feature is 112. The question is, all these 112 feature will create a neural network or support vector machine having 112 input and only 2 output. Good, bad. Having a problem, no problem. So you don't know whether all these features are important or not. So that's why we do very optimally what are the best feature, which wavelet transform and which particular feature you want for level 1, level 2, level 3, because frequency band I have to. So that means for the particular task, which frequency band is much more effective, or which features are much more effective for a better classification accuracy. So that is the main idea, where you can see now energy feature, the performance and train test ratio. You have started 10% to 10% train, 90 test to 90 train, 10 test. you can see all these features. If you look into the green one, all 112 features are not good always. So some features are best other. Okay, so that is the way how we can do the classification accuracy increasing. Similarly, we have applied to the forecasting model. Some applications are done on the forecasting. So what exactly we are forecasting? We are forecasting either you can forecast the load, you can forecast price, you can forecast electricity, you can forecast monsoon, you can forecast the dollar price, you can forecast anything. Okay. So when it is a forecasting problem, it is a time series problem. I have a certain time series. So, but the very important thing is the data preparation. What are the input? Because for example, I'm giving an example. If I want to forecast tomorrow 10 o'clock, what will be the electrical load? It must depend on the previous value. It must depend on the previous 1 hour, previous 2 hour, 1 day before. So that's why you look into the data which we are preparing the forecasting. That is very important. Just I will tell you this one. You can see I want to forecast P. P may be price, P may be power, P may be anything. For PT, so I have to make a time series. PT is dependent on, so PT is the output. What is the input? The input is PT minus 1, PT minus 2, PT minus 3. That means what is the price or rain or whatever you want. 1 ghanta pehle, 2 ghanta and 3 ghanta. So mean 1 day before PT minus 24 to minus 25. 2 days, 48, 49. 1 week, 24 into 7, 168, 169. 336, 337. So likely you have to make it the time series. You have all the data for 2 years, 3 years, 4 years, 10 years. And again, you have to look into the pattern. For example, if I am putting the monsoon having certain period. If I want to predict the price of the electric load, then I have to take a holiday and a non-holiday. So that's why some expertise is required in preparing the data. Many researchers tell, okay, so it's very critical how to prepare the data. No, data preparation is dependent upon your own expertise, how to put that in preparing the data. And again, here also, what is the optimal? Can I go for 10 years before? Like to 168, 169, 336, 337, then you multiply it 1 year before, 2 years before. Oh, no end to that. No end to that. So that's why this is one thing. And the other thing which I want to tell you here, you just see the first one, the black figure is the time series data which I want to forecast. So every forecast, every time series data is having a trend and having a fluctuation. So here what we do, we apply the signal processing technique, wavelet technique. We decompose this data into a smoother version and a dilation version. So instead of forecasting the data itself, you forecast the smoother version one by a very simple neural network and the detailed version one by another network because it contains a more spike. So then you add both these forecasts. That gives a better result. Okay. So this is which we have applied and we have done it by extreme learning machine. So in extreme learning machine, these are the different level 1, level 2, level 3, level 4 wavelet decomposition, and we try to find out what is the maximum absolute percentage error. Because I am just putting you. Then here also, which activation function is good, whether sigmoidal, sine, Hadr limiter. So always you can do all this business to find out the optimal combination of the features, okay, and the optimal size of the extreme learning machine, the optimal mix. That means what will be the transfer function for the better prediction. You can see this is the prediction, actual and forecasted. You can see the difference between actual and forecast whenever there is a spike. So this spike will be reduced if you apply the wavelet transform and you do that. So again, in the forecasting, the uncertainty is to be handled. That I have told you, the prediction interval and the confidence interval. I want a very narrow prediction interval and I want a very high confidence interval. So those are the two statistical things which people can look into for the forecasting and the uncertainty in forecasting. So these are the some application I have discussed to all of you, uncertainty, and these are the application of NN and ELN in those particular application of forecasting one. And I'm not going into the result, you can see. So here what happens, we forecast a upper prediction interval and a lower prediction interval with a narrow band. That is the most one. So you can see the actual, the upper PI and lower PI. PI is the prediction interval. If anybody is interested, you can look into all those papers which are published by us and others also, and you can get a lot of idea about the forecasting and uncertainty forecasting, how to handle this uncertainty in forecasting. So maybe I may close here because at 11:30 I have another meeting. So we can discuss something if you want to ask to me. Yeah. Are the participants there?
We are here, sir. Actually, we are listening in front of the seat. Okay. So actually, one participant have one like question. So I will ask him to come in front of the camera.
Yeah, please.
Sir, you have already told in your lecture that that in case of PSO, you have two parameters, that is C1 and C2, right? And C1 will be the value of the C1 is 2.1 and the value of the C2 is 4.2 according to the problem statement. So is there any way to choose the value of C1 and C2? Or is there any technique, or like you are telling the 2.1 and 4.2, on what basis that value is been assigned?
Yeah. You see, let me tell you, when PSO was invented in 1995 by Eberhard C, they have taken C1 and C2 are 2.1. Then you get another paper by Maurice Clark, where they have taken Phi1 and Phi2 will be greater than equal to 4.2. Okay.
Yeah.
Into a paper by Passino and Gaji. That paper clearly describes for the stability of the swarm and for the convergence of the swarm, what must be the maximum value of C1 and C2. Okay. So, because if you look into the equation of the PSO, these are the dynamic equation. X dot equal to Ax plus Bu. If anybody is interested in the control, you can find X dot. What is X? X is a state. You have two states. One state is the displacement, another state is the velocity. Okay. So, velocity is the displacement derivative, X dot. So X dot equal to X plus Bu. U is the control variable. The control variable is C1 and C2. So that's why looking into the problem, instead of taking a fixed value of C1 and C2, you know what is the maximum value. Okay.
Yeah.
How it will change depending on the. So anybody is interested to find out the stability of the swarm and the convergence of the swarm, please refer to a paper by Passino and Gaji. You will get a lot of application, but of course it is based on the control theory. Okay. For which value? Now you see, suppose a particle is here. It has to go to the global maxima. If you can see my finger, the global maxima. So how it goes? It may go like this, a chaotic motion. So finally it will come, or it may go like this, a streamline motion. So what is motion? Motion is the change in velocity, change in position from one point to the point, which is governed by W, C1 and C2. It must be in a smoother manner so that the algorithm will have a convergence and the algorithm will have a stability. So the convergence and stability of the swarm in PSO is very, very important and well studied. And I leave it to the mathematicians, those who are doing the mathematical analysis of the control system. They can study it very well and find out the value of C1 and C2.
Okay, sir. Got it, sir. Got it.
Thank you.
From the online participants, is there any query? So I think there is no query from the audience.
Thank you. I'm sorry because I have another meeting at 11:30. I have to leave.
Okay. Thank you so much, sir, for your presence. Is make our days very informative. Thank you so much, sir, for joining.
So thanks to Somen and Professor Bhattacharya and all of us who are there. Thank you.
Thank you.
How to leave it? Yeah, I have leave it.
Okay. Thank you so much, everyone, for joining here. So now we are going to start our sessions for paper presentation. For that, we are having the session share with us, Dr. Ankan Bhattacharya, Mr. Snehashish Banerjee, Dr. Somnath Chakrabarti, Dr. Joydeep Sengupta, Dr. Abhishek Das, Dr. Sahadev Roy, and Dr. Diganta Sengupta. So I ask all the participants kindly join the respective meetings for present the paper.